Welcome back to another video on Ramda JS. And in this video we are going to talk about the function ends_with, but we're also going to talk about the function starts_with, because as you can hear, they are probably sort of the same function, but one looks at stuff in the end and the other one looks at stuff in the beginning, so in the ending or in the start. And last time we talked about the function empty, and I guess before that we talked about either. Yeah, exactly. So in either, we also sort of dived into applicative functors, and when we talked about empty, we also dived into monoids, which also brings us into semi-groups and all of that stuff. So there's been, in the last few episodes, there's been sort of a lot of borderline category theory, and we've sort of dug down the rabbit hole quite deep. So hopefully you found that interesting, but if you found that extremely frustrating, then rest assured that this video is going to be much simpler, because ends_with and starts_with are sort of just normal functions, right? Or like normal, just like here's a function that does something. But let's also talk about composition as we get into this, because we're going to talk about how to construct this function. So let's just dive into it. I mean, what is ends_with? Well, ends_with is essentially a function that asks whether a particular list-like structure. Actually, you could probably make an implementation for ends_with for monoids, but let's no, actually maybe not. Yeah, let's not think about that now, right? Okay, but if you have something that's list-like, such as a list of strings, or a list of characters, sorry, which is a string, or a list of anything, then you can pass some subset or some okay, so what am I saying? Let's restart, right? If you have the string hello and then you ask if the string hello ends with LO, then that's true. But if you ask if the string hello ends with, I don't know, XO, then it doesn't, right? Because it's not helxo, it's hello, right? So the two final characters are L and an O. And so what I was saying is just that if you look at the type definition here of ends_with, you can see that there are two type definitions. One is for strings. So if you have a string, one is for lists and one is for strings. So if we look at the first one, then we're saying if you pass a list of A's and then another list of A's, then you get back a Boolean, right? So this is the potential substring that we want to match against. Rather, I should say, the potential sublist that we want to match against. So we're asking, does the bigger list contain this smaller list? And then the next argument is the bigger list, and then we get back a Boolean. And then it's exactly the same thing for strings, right? Where it's like, well, if you pass first you pass the substring that you want to check whether the bigger string matches in the end, or like if it ends on that particular string, and then you pass the bigger string, and then you get back a Boolean. We're gonna look at this in code. We're just gonna experiment with it, but probably you can see how that works, right? It's like, again, so in the hello example, if we look at for strings, then this first string would be LO, and then the second string would be hello, and then what we would get back is true. But if it's false, then maybe we pass XO as the first string, and then hello as the second string, and then we get back false, of course. But, and yeah, I mean, I think you can think of a string as a list of characters. So in some sense then, like in languages where a list is actually just syntactic sugar around the idea of a list of characters, then this first type definition would also cover that, right? Because then the implementation would hold for a list of characters, just as it holds for like a list of objects or a list of anything else, right? A list of numbers or whatever. So then we wouldn't really have to specify this special case, let's say. But let's jump into Node, right? And then let's just say const r equals require Ramda, so that we have Ramda, and then let's just try to experiment with it. So let's say just check if we have the function ends_with. We have it. We can see it takes 2 arguments. So if let's do exactly the example that we talked about, right? Let's say we pass LO and then we pass hello. Yep. And then, yeah, that's it, right? And then you can see we get true back. But if I pass XO as the first string, we get false back. Actually, let's see if this is case sensitive, right? Presumably it should be case sensitive. So if I pass LO uppercase, then that doesn't match. And this is it, right? And of course, you can do the normal stuff like currying, partial application, because this function is auto-curried. So you could say ends with LO and then say let f be that function, so that you have this function that you can reuse and pass around. And then now you can pass a bunch of strings to that, like hello lowercase, and then maybe hello uppercase, and then you can see in one case it's false and in another case it's true. But this you're all intimately familiar with if you've been following this series, right? Like we've talked about partial application, all that, like tons of times. So this is essentially ends with, right? There's no more magic to it, and I guess you can totally see how that works. And as per their examples here, you can of course also just use lists of things. So we could say R ends with, let's say, if we have the list 3, 4, for example, and then we're asking whether the list 1, 2, 3, 4 ends with 3, 4, then that's true, right? But if we ask whether it ends with 3, 3, then that's false, because that's not what the list 1, 2, 3, 4 ends with. The list 1, 2, 3, 4 ends with 3, 3. And of course, we could have done this with sort of, I guess, like arbitrarily complex things. Let's say, so I'm wondering now, I got quiet because I'm wondering if I pass in two objects that have different memory locations but have the same structure. I'm not sure if they're going to compare by structure or whether they're going to demand memory location equality. So let's just try that, right? Like, let's say we have the object foo pointing, or let's just say n pointing to 1, and then we have so that's the list that we want to, or that's the thing we want to find in the end of the other list that we are comparing against. And then let's make a bigger list where we simply have, well, let's say n0, and then another object where it's n points to 1. And then let's close that. Yeah, so actually they are I presume recursively digging down into structures to check whether they are equal in a structural sense rather than as in a memory location sense. We've talked about this before. I'm a bit confused. Have we talked about the function equals? I assume we've talked about the function equals. If not, then we're going to get to that, because I'm just thinking like, yeah, probably the next episode, since the next function is eq_by, and then ek, or maybe I should say ek, right? Ek_by, ek_props, and then equals. So I'm not sure. I'm going to dive back. There's been too many videos, so I can't really keep track of which ones we've talked about or not. So explicitly, we're going to talk about equality in the next, equality, sorry, not quality, in the next video. But presumably, we've talked about it a bit back and forth, sort of by necessity, right? Since we've talked about, naturally the subject has come up in other videos. So again, we are not. In JavaScript, for example, if you just use plain JavaScript and you have the object n1, for example, or the object. An object with a key n pointing to the value 1, and if you ask whether that's equal to another object with the same structure where you have a key called n pointing to the number 1, then that's false, right? Because these are two different memory locations. Well, in JavaScript, what we need to do is we need to say that, let's say we have this variable x in which we store that object. And if we then say that ask if x is equal to x, then of course that's true, right? Because then they're pointing to the same memory location. But again, like, sorry, what I meant to run is this, right? But if you have just two things with the same structure, then yeah, that's not, those things are not equal. But in Ramda, if we run equals and we pass the same object, right, n, the key n pointing to the value of 1, and then another object with the key n pointing to the value 1, then those are equal in the Ramda sense, right? Equals will say, well, those two things are equal, and then like necessarily they have to be equal, right? If you have another property in one of the objects called m, and that's also equal to 1, let's say, then they're not equal, of course. It's just that one is sort of a subset of the other, or like one contains some pieces that the other one contains, but that's a more complex scenario than just straight equality. But anyways, okay, so they're probably using equals in this ends with function. And of course, we also have starts with. I just clicked starts with here when they said see also. And then you can see it's sort of not the inverse, but I mean, it's like, it's the same thing, but for the beginning of a list or a string. So actually let's go back to ends with. I didn't read the text here. Let's just read the text. It says, okay, checks if a list ends with the provided sublist. Similarly, checks if a string ends with the provided substring, right? So sorry, that was a more clear way of describing it than the way I described it in the beginning. And if we jump to starts with, you can see if I jump sort of back and forth, you can see the texts are like exactly the same. It's like they've just replaced ends with starts or starts with ends, right? So it's like for starts with, it's like checks if a list starts with the provided sublist. Similarly, checks if a string starts with the provided substring, right? And then we can try that as well. We can just say, okay, does let's say we want to check if something starts with 1, 2, 3, and we have the list 1, 2, 3, 4, 5, 6, 7, let's say, right? Then that's true, because the list 1, 2, 3, 4, 5, 6, 7 starts with 1, 2, 3. But if I do the same thing for, let's say, I mean, if I say, does it start with 1, 2, that's of course true as well. But does it start with 1, 3? No, right? Because it starts with 1, 2 first, and not 1, 3. So same thing, and you can also do that on strings. Let's jump back to ends with, right? And let's jump into the source code of that function in Ramda, because I think it was interesting to notice that we talked previously about the function take last. So just have a read through. I need to let the cat in, right? But have a read through this function. I'll just let the cat in. Hang on. Okay, interesting, right? I mean, so we've talked about take last before. Actually, we've talked about lots of different ways to take values from a list. Actually, let's jump back a bit here. Let's see if we can just see that very quickly. No, wait, sorry, I'm realizing. Yeah, sorry, we have talked about it. So I was confused because we talked a lot about dropping, but while talking about dropping, we also talked about taking, right? So here's take last, for example. So did they use take last? Yeah, take last. So just as a reminder, right? Take last. Sorry. Take last returns a new list containing the last n elements of a given list. It returns a list of list.length elements, right? So wait, what is that list? Oh no, sorry. I was jumping the documentation. So it returns a new list containing the last n elements of a given list, right? And if n is greater than the list of the length that we are asking for these the last elements from, then it just returns the whole list. But if you see this example here, right, when they're saying, okay, take last 2 from this list of 3 elements, then you get the last 2 elements. So if you have a list of foo, bar, baz, then you will get back bar and baz, because those are the last 2 elements if you were asking for the last 2 elements. So that's take last, right? We're just taking a bunch of last elements. And so the interesting point here is that then this is like a function composition here. It's like they're saying ends with is the composition of equals and take last. So it's equals after take last, but equals with the suffix. So what I'm trying to say is that if we actually define this ourselves, I assume like maybe for performance reasons or maybe for readability reasons, they haven't defined this as a function composition, but I'm pretty sure we can, right? So let's just try to do that. So like, let's say we want to define our own ends with. So let me just say let ends with be a function, and then we're going to say that is the composition, so compose of what? Well, we want to say, so we need to take 2 arguments, right? So ends with takes first an x, which is, or let's call it end, right? Like the variable end. So it takes first an end, and then it takes some whole, right? And it's like we want to ask if the whole ends with the end, right? That's sort of the implementation. But I think since we're doing composition, we can probably do this point free and just take the end variable, right? So ends with, given some end, is the composition of asking if the end is equal to or like the composition of, yeah, exactly, asking if the end is equal, no, sorry, if the, yeah, it's tricky because I call this variable the end. So it's the composition of asking whether the contents of this end variable is equal to the result, yeah, so I'm expressing this a bit funkily. It's okay. Let me remove the word composition from that sentence. So ends with is the result of asking whether the end variable is equal to the result of taking the last elements from the whole, where the number of elements that we are taking from the whole is equal to the length of the variable end, right? No, check this out. What I mean is take last. Let's just check the syntax of take last. I can't remember. So it's like we're saying take the last n elements of some given list, right? So this is an excellent syntax. This is also why let's just pause for a moment and reflect over how partial application is especially powerful, or currying it is especially powerful when the one designing the function really thinks about which order is probably the most common order to apply arguments to this function. So in other words, we don't need to sort of flip arguments back and forth with these functions. I think it's just going to work by simply just applying one argument at a time, because the one who designed the order of the arguments that these functions need, essentially just take last in this case, made a good decision, right? It's like, in this case, we want to partially apply the number, but we don't yet know the list that we want to take last from, or like we don't know the structure or the whole that we want to take the last part from. So yeah, let me think about this. It's like we're saying take last of end.length, something like that, right? Yes, and it's that composition, and let's just close that. Let's just see, maybe I'm wrong here, right? But let's see if that works. So if I say ends with, and we say, okay, is 1, 2, 3, nope, so yeah, the other way around. So let's say 3, 4, is that the ending of the list 1, 2, 3, 4? Reference error take last. Okay, sorry. So I defined the function incorrectly, because of course I need to say r.take last and not just take last, because I forgot to reference the function within Ramda. Okay, so now we have ends with. Let's try that again. Actually, yeah, and I should have noticed because... no, sorry, not necessarily. Never mind. Okay, but yeah, let's try that again. That didn't work because we got back a function rather than a result. So let's think about that. Why is that? Can I do toString on this to like get the implementation? Okay, that's not helping at all. Because let's just think about this. It shouldn't matter whether I sort of partially apply this or not, right? No, it does. Or like if I run it in this way. Yeah, so probably that's why. Okay, sorry. Yes, of course that's why. Because now we are defining a function that explicitly takes an argument. So then that means if we want to pass 2 arguments to this, then we need to curry this function. So if we wanted this to actually be... Yeah, if we wanted this if we want to be able to call this function in the way that we did first, with sort of 2 arguments, then we need to use r.curry. And then sort of wrap our whole function in r.curry. This should probably work, and then I can probably call it... No, I can't call it like before. That is funky, I gotta say. Because then you have a function that takes 1 argument. Okay, sorry, it's probably... So this is a quick sidetrack. Let's just try to figure this out. So curry n is what it's called, right? So you specify a number, right? So probably Ramda can't know how many arguments we want to have, or rather it knows, but it's assuming that it's 1, because we actually only have 1 number, but we want 2. So let's say curry n and then pass 2. Let's just try that now. So if I then have ends with, I want it to have, yeah, the length now is 2. So if I run ends with like that, damn it. Okay, why is that not working? I'm a bit confused now. Because, so, let's just do it this way. Okay, let's just copy this, the actual composition, right? Let's look at what we get, whoops, here. Okay, sorry, let me just clear some lines. Okay, sorry, so end is not defined here, but let's just say, let's assume that it's taking sort of the last two. So if I compose equals, equals using foo, and then I'm taking the last two, so sorry, then it should be maybe fo. Then I get back a function, and the length of that function should be 1, right? And so then I can apply that to, let's say, fo, and then that would be true, but foo, that would be false, right? So, I mean, our composition works correctly. It's just that, of course, we are not successfully, so I'm just trying to figure out why can't I create a function that can be called by passing two arguments like this and sort of has to be invoked like that with sort of this like explicit partial application syntax. We want to have, we want to be able to sort of nicely call it like this because we're trying to sort of rebuild the take last function using composition. So, and of course, I mean, you should also, like, back to this, I was reading, I was struggling how to describe it in words. Of course, what we're doing here is that we're saying that when we define the function ends with, we are saying, let's go back to this one without currying here, right? Then we are saying that it's the composition of taking the last elements followed by asking whether that result is equal to the end, like the end variable. So it's like r equals end after r take last end.length. But let me think about this. Why am I messing this up? Let's go to curry, right? Is it like that we should uncurry maybe? Returns a function of arity n from a manually curried function. Sorry, that's my mistake. So we shouldn't curry, we should uncurry probably. So we probably want to say uncurry 2 and then pass this function here. Let's try that. Sorry, not uncurry, but uncurry n. Let's just try that and then let's see. So ends with now has a length of 2, and if you call ends with like this, now it works. Okay, my bad. We didn't want to curry it, of course, because when you curry a function, you turn a multi-arity function into a single arity function, or a unary function. You turn an n-ary function, for example, into a, you turn an n-ary function, like a function with n number of arguments, a function taking n number of arguments, where you know the number of arguments that you need to take, and you turn that into a single argument function or a series of single argument functions. I mean, you curry the function so that it can be partially applied. But what we had is actually an explicitly partially applied function, or a manually curried, as they say here. No, not explicitly partially applied. That was incorrect by me. An explicitly curried function, a manually curried function, where it's like you have a function that when given a value, it has an arity of 1, and then when you give it a value, it gives you back a new function that also has an arity of 1. That was the problem that we have. So when you have that problem, you need uncurrying, because you need to say, I have a function that has I have a series of functions that each have an arity of 1, and I want to unravel them so that I get back a function with multi-arity. But actually, if I think about it, that means that we can't call it curried anymore, right? No, we can. Okay, how come we can that? Yeah, because it is manually curried, right? So we are not. Yeah, I'm not entirely sure about that. I'm wondering whether that's an unintended consequence of us actually having a manually curried function. But then, I mean, you use this when you have a manually curried function. Yeah. So I'm thinking about whether this always is the case or whether this just happened to be the case here. And what I mean with this is that when you uncurry, does that mean that you decide that that it's not possible to call it in this sort of parenthesized way, in this sort of, let's call it explicit partial application way, or does it, but that sometimes you get both of the syntaxes? Is it like you're deciding that you can only call it in this multi-arity way, or can you still sort of call the curried version of that function? It's just that you're also enabling the multi-arity way of calling that function. I would assume that actually it's like if you have a manually curried function, then I would assume that the result would always be that you have something which supports both syntaxes. But yeah, I may be wrong. If you know what the answer is to that question, do shoot something in the comments. Either way, now we solved the problem for our own ends-with function. So you can see it's by using uncurry or uncurry n, sorry, and I mean, even if we didn't do uncurry n, the key point here is that we used composition. We composed the function r.equals and the function take last. And you can see, I mean, depending on how much of a fan of point-free functions you are, it's definitely possible to turn this function into something which is entirely point-free. I mean, now we still have one explicit argument, which is this end variable here. But you could, of course, turn this into a truly point-free function and get rid of that. But I would just, I didn't really think about how to do that now, but also because I would assume that just there's a sort of trade-off you have to do, right? Where it's like I would say that this is highly readable, but if we try to get rid of that point as well, it's not super obvious that it's readable. Because let's think about it. I mean, since we're also getting the length here from the end variable, right? I mean, this could also be written as r.length and passing the function end. Did I mess up the syntax here or not? No, okay, so that still works, right? So that also works. But let me actually remove this uncurrying. Now we know that works, but let me remove that so hopefully it fits on one line. Yeah, almost, but this is a bit easier. Oof, too bad. But this is at least a bit easier to read. Like this, right? So then we have to call it in this sort of explicitly partially applied manner, but at least the function is a bit more condensed just now when we're talking, right? So since we can sort of do, I mean, clearly accessing the property length isn't necessarily necessary. You can also just pass the end variable through the length function, which means that you could also express this second piece as a composition or as a pipe, right? Where it's like take last after you've take last from end after you've asked for the length. So let's actually, I mean, we could do that as well. Let's say it's R.compose, R.take last, and R.length on the value end. Oops, do I have an extra? Yeah, sorry, like that, right? And does that still work? Yeah, that still works. And if I change it, like if I change the list that we're checking whether we've successfully found the end from, we can see that like it still behaves according to specification. But now, I mean, this is, yeah, maybe not super obvious. And of course, like maybe you would argue that, okay, but it would be more clear to use pipe, so maybe we could use pipe instead. So like, remember, I mean, compose is right to left composition, right? So the rightmost function first and then the leftmost. It's like when you say compose and then you pass function A and function B, then it's like you first run function B and then you run function A. But when you have pipe, then you do left to right composition. So when you pass function A and then function B, then you first run function A and then you run function B, right? So it's exactly the same concept but reversed. So maybe we would do that. So we would say, well, we just pipe, right? We pipe first r.length and then and then r.take last, and we pass the end variable to that. Take last, and then we pass the end variable to that piping, like to that composition, and then we pass r.equals, and then we pass the end variable to that as well. And then I think I need one extra parentheses here, right? Like that. And this, I guess, would have exactly the same effect. 1, 2, 3, 1, 2, 3, 4. Yeah, that works as well, right? So just think for a moment about how we could turn this into a totally point-free function. Sorry, just cats again. Okay, so I'm not entirely, just check this. Yeah, I'm not entirely sure, but if you think about it, what's going on here is that we're passing the end variable in two places. So we're passing the end variable in this first function, and then we're passing the end variable in this other function. So I guess, let's just actually, I mean, for good measure, let's just try to figure this out. So there's the converge method, for example. So then we're converging using some single convergence function, and maybe that would be, I'm just thinking maybe we could use pipe there. And then we want to pass the value that we pass into every other function, right? So, and that's the end variable. So we want the end variable to be passed into this first pipe and to the second, and to the equals method. And then we want to converge over another pipe. So let's just actually try that, right? So let's say that would be something like R. I have no idea whether this is going to work, right? But probably, I'm guessing, right? So we're converging over pipe, and then we have a list of functions, and our first function is a pipe where we first ask for length, and then to take the last on the basis of that. So that's our first function, and then our second function is r.equals. And that's gonna then, yeah, and then that's gonna be past the end variable, which is going to return a new function, right? So then so this first thing is going to return a function when it's being passed one variable, and the second thing is going to be return a function when it's being passed a variable. Whoops. Which means that we then are passing like valid arguments to the convergence function, which is pipe, which should then give us back a new function to which we can pass the second argument. So let's try that. Does that work, right? Let's just ask ends with dot length. What's the length of this function, right? It has a length of 1, so that's good. Let's try this. Didn't work. Why does it not work? Maybe this is one of these moments where I should not dive too deep into this because we could lose hours here. I would assume also it's something that, so if I apply the first argument, then it's expecting some second argument. Okay, sorry, this is this issue with converge where I probably need to say, no, I can't. I learned this issue in another video, and then even still, I can't remember it. It's probably something about the arity. So let's think about this. I mean, pipe here, yes, it's probably something like this. When I say R equals, I want to say that R equals should be a one-ary function, which is the same thing as calling R.unary on R equals. I think that's the issue. Yes, right, and let's run. No. So unfortunate, because ends with, if you ask for the length of that has a length of 1, right? And if you apply that to empty list, then you get back a function that expects one argument. If you apply that to another, empty list, then you still get back a function. That's odd. Right, so I don't know, I don't even know what that is, right? Let's just pass another empty list, and that's true, but that just kind of makes no sense. Yeah, probably I shouldn't dive too much into this. There is something also called the s-combinator. I'm wondering if that's the sort of answer to all our problems from SKI combinator calculus. So if you just look at the definition here at Wikipedia, if you call s and then you pass 3 arguments, x, y, z, then the new function that, or the new thing that will be returned is that you apply z to x, and then you apply z to y, but then you call the first function with the second one. Yeah, so that's not exactly, yeah, but we could use that, right? We probably definitely could use that. But then, but then what, right? But then equals needs to be, yeah. Sorry, we are indeed messing this up, right? Because you have, yes, because actually that makes a lot of sense. So I don't know if Ramda has this s-combinator. I mean, I haven't found a function called s, but let's just, okay, this is a quick sidetrack. Let's try to figure this out, and then I'll drop this. I think this is actually particularly, or pretty interesting. So let's define the function, like the helper function s, which takes an x, a y, let's just actually do it like this, an x, no, we have to do it partially applied, an x and then a y and then a z, and then it calls x with z, and then we assume that that returns a function, because then we call that with the result of calling y and passing z. I think this should be it, right? So then we should be able to use s to solve our problem, right? It's something like ends with should be equal to, sorry, actually maybe the previous one did actually work. I just forgot to remove the point. So before we dive into, I forgot to remove the argument. So before we dive into s, let's actually just see if we actually solved it before. What I mean is here, we still have this end variable here, which of course we needed to remove, and that's probably the reason we had this extra argument, because now we are talking about a truly point-free function. So let's see if that works. Ends with, and if we call that like this, that actually works. Okay, so our usage of converge was actually correct. Our assumptions about converge were correct, and it actually, the implementation that we wrote actually worked, except that we had to remove the argument, and that argument is what caused the function to expect another argument. So let's see, do we still need to specify this unary thing? If I don't do that, then it doesn't work, right? So we still need to say that R equals should be treated as a unary, like, where did I put that? Oh yeah, never mind. Let's just do this. Yeah, like this, right? Where we say, maybe I should make that full screen, right? Where it's like the unary function, or we're passing equals through this unary function. Sorry, let me just rearrange the screens a bit like this, maybe. That's a very small browser window. Anyways, so, and this, I've mentioned this is in another video. I'm not entirely sure why this is, but there's some interaction, or there's some issue with, or I mean, essentially the cause of the problem is that when you are dealing with variadic functions, then you can't have currying with variadic functions. This I've talked about lots of times, right? Where it's like, because if you curry a function that's variadic, you don't know when the partial application is completed and when you should return a result, as opposed to just returning a function that accepts the next result. So we have to say, so the implementation of converge will check the length of all of the functions that are passed in this array of functions, and so hence we need to. Whoops, sorry. Now, let me just. No, I can't clear it, but let me bring back this. Right, so here. So we need to say that R equals is a unary function, because we're only expecting this first function to be passed a single argument. So then we should demand that this second argument is also just passed a single function. And in other words, return the resulting function rather than force the function returned by converge to accept multiple arguments. I understand maybe my explanation is a bit shady. Do check back in the other videos for more explanations on that. There is a video, for example, explicitly on converge. But yeah, and sorry, now I have accidentally introduced this point again. This would be the sensible implementation, right? Not with this argument, because now it's truly point free, and that works. Now, should we think about whether we can do it using s or not? Let me just say, okay, if this is all you care about and you don't care about using the s function that we talked about now, thanks for watching the video. I will see you in the next one, right? But now let's just try to solve the same problem using s. So remember, this is the definition of the s function here that we have here in Wikipedia. Whoops, now I lost it here. So how can we do that? We should be able to somehow, if we start with equality, right? It's like, it's that we're saying s over r dot equals, and then what's the next thing? Sorry, I have to let the cat in, but keep thinking about this. So, I mean, z has to be, z has to be the whole string. So we can't just say equals here. Actually, we need to say, we need to get the last, yeah, but that's the tricky part, right? We need to get the last, let's think about the previous implementation, right? We need to get the last piece of the whole string, where that whole string, yeah, so actually take last needs two arguments, right? So we first need to apply take last to, oh, this is a bit tricky. We need to apply take last to the length of so actually, yeah, it's tricky because we have two arguments, and that's what I'm messing up, right? Because ends with actually takes two arguments. It takes the end string and it takes the whole string. Yeah, so then we have a point anyway, right? So it's not as simple as this s-combinator, right? Because this s-combinator assumes that we have only a single value in. So I need to use, yeah, no, exactly. I need to use something else still in order to get rid of that point. Because if we all, like if we had this scenario again, where it's like, well, you allow yourself to take one argument, which is sort of this end variable, then it's kind of trivial. Then we should be able to use this s-combinator fairly simply, and then use that to return a function that you then apply the whole string to. But that's not what we want to do. I mean, we want to actually get rid of the end thing, which means I'm probably going to have to use s twice, which is going to be a serious headache. And this is surely when we are hitting the point where not the return on investment, but the sort of cost-benefit analysis is pretty shaky, right? Because that function is probably not going to be very readable, as opposed to, I would say that this converge function is adequately readable, maybe, right? I mean, I would probably prefer the original implementation that we had that actually had this point, not with the compose here, but this function, right? This is actually pretty readable, I would say, and that makes sense, right? We could do that. Of course, I mean, maybe the easiest thing to read is just sort of their very explicit implementation that they have in Ramda. This is, of course, maybe even simpler to read. But I mean, if we really want to make use of composition, I think that was an interesting exercise. But let's think about this one last time. Can we make use of yeah, but that's just identity and constant. So can we make use of s here, I guess twice, in order to figure this out, right? Let's just solve the first problem. Like, let's assume we have the end variable as an explicit argument. Then the end will be passed to both, which means that the two functions that we have essentially are these two functions, right? Where let's think about it. The first could be Yeah, R.pipe, R.length, R.takeLast. No, the first one has to be, yep, exactly. The first one has to be equals. So R.equals, yeah, because then equals will be past the z, which is the end, which will give us a function that we can compare the second result to. And the second result will also be past the end, and it will check the length of that and then construct a new function that it expects to take last. Aha. Aha. But then that doesn't work, right? Because that thing does not expect, that thing is of course not equal to this thing. That thing expects the second argument, which is the whole list. So actually, yeah, and this is probably when we need this double, yikes, double S somehow, because then I want to have, so I need to get the whole list in somewhere. I mean, it's also, I mean, if we read their implementation, right, it's like we're asking for equals. So where the suffix, yeah, so they're called, what we called end, they call suffix, which is probably a better name actually. So this is probably the way we should think about it. It's like suffix needs to be passed through length and then passed to take last, and then we need to pass the list here. So we're piping suffix through, yeah, we're just, yeah, exactly. But that's what we're doing. We were constructing a pipe that takes the suffix and then take last. Or sorry, we're constructing a pipe of length and then take last, which then takes, when given the suffix, will return a new function that accepts the list. So then we have to give that the suffix. So that gives us the first function. So maybe that needs to be part of a pipe. That gives us the first function, but then we want the other one to also be past the suffix. Oof. So take last. What am I messing up here? I don't think I need double S. I'm just being really confused right now. I want to, I'm sorry, I'm running out of time. I have to go in like 2 minutes. I really want to like crack this nut. Crack this nut. Sorry, was what I was attempting to say. Because we're piping, so whenever this thing, yeah, sorry, so maybe what I'm doing wrong, yes, sorry, what I'm doing wrong is that it should be this, in this order, right? We should pass R equals here. That's what I'm messing up, right? Because then the suffix, let's call it, instead of end, let's call it suffix. And actually, we don't even need it explicitly now, right? We're just saying, if you pass the suffix, then the suffix will be applied here, and that will give us a new function that awaits the whole list. And it will also be passed here. No, but it's still not. Yeah, because this thing in that case needs to give us the whole list and not just the suffix. Yeah, okay. I'm gonna have to give up. Exercise for the reader. I really have to go like right now, so if I figure this out, I'll post something in the comments, and if you're faster and you figure it out, do shoot something in the comments. I'm really curious, do we need like double S, or do we need single S? Or is there a simpler way of doing this that would make it truly point-free? Yeah. Whew. So disappointing, but that's so interesting. I want to know. Okay, if you know, or if you figure this out, do shoot something in the comments. Thanks a ton for watching. I will see you in the next video or in the comments section. Thanks for watching.